Hey, welcome back. Today we're going to look at a more traditional AI, which is nlp.js, which is a JavaScript natural language processing library. And in fact, in our quest to build this AI agent network, I thought that bringing nlp.js into my agent network would be a really sensible thing. So where we were in the last video is we actually made a time service using bun and WebSockets, and of course we ran into a problem. And I'm going to show you what that problem is and how we can solve that with nlp.js, which will then in the future allow us to train some large language models and create these agent networks. So just as a quick recap, we created a WebSocket server in bun, which acts as a time service. So when you connect to that service with your WebSocket client, it will give you a basic welcome message and tell you what sort of commands you can perform. I will connect up to that in Postman, and you see here, if I click on the connect button, it says, welcome to the time server, ask what's the time and I shall answer. So I've already put in my message column here, what's the time? And if I hit send here, it comes back and it says the time is 7:18:22. Yep, so it's giving me an accurate time because in my code here, I've got this sort of check here that says what's the time, and then it will go calculate the time, and then we send back the time is whatever the current time is. Now, the problem with that is if I send anything other than what's the time, so if I misspell this in any way, such as what's the time, then you are going to see when I click on the send button, it says I can only tell you the time if you ask nicely. Even if I put an S on at the end there, I'm going to get the same error. If I word it in a different way, tell me the time, then it's going to come back and say, I can only tell you the time if you ask nicely. So it doesn't handle those variations. And if we think back to the sort of 1980s and expert systems, this was exactly the reason expert systems failed, is because, you know, they were very brittle in nature because you had to ask the exact questions that you wanted. And if you didn't ask it in that way, then it failed. We're in that scenario here. So if you haven't heard of nlp.js before, it's a fairly old library. It's like 5 years old, but it, you know, the last updates were like 6 months ago. So it's still in a sort of fairly decent enough state there. But what it does do is it provides sort of basic natural language capabilities. So if you look at the GitHub, it's at GitHub AXA Group nlp.js, and you can see out of the box it supports things like tokenizations, it supports sentiment analysis, it supports named entity recognition, and of course it supports things like natural language processing classifier, which is what we are going to use here. Now, actually, if you look here, there's a nice little animated GIF that's kind of showing how nlp.js works. So there you go, ask question, who are you? So that's the sort of intent. It says, and then you can answer back with, I'm a virtual agent. When's your birthday? And then it's going to come back with an answer. And it's using this technique of being able to sort of recognize those intents or utterances and then be able to use the classifier as part of it to then route it to the answer that you want to be able to give. And then if you think about my scenario of a time server, which is running a WebSocket server that is going to understand different queries about the time and then be able to come back and sort of return what the time is. That's exactly the same scenario that I'm looking to be able to run here. Yeah. So good news, is fairly easy to get started with nlp.js. So I am just going to take the time server that we created earlier, and I'm going to add node NLP to it, which is the nlp.js library. So I'll do that by just doing bun add node NLP, and then that will add that to my package JSON. Okay, so now that that's installed, we can create something very quickly to sort of test this out. So I'm going to open back Visual Studio Code. This time I am going to just create a new file. We will call it nlp.test.ts. So if you think about what my basic test is going to be, I want to train one of these neural models, this classifier, with variations of my question. What time is it? What the time is, etc. So that it can learn those variations, and therefore when I send through anything else, then it's going to be able to return back what the right time is. So I'm going to do NLP manager is my import, and that's going to be from node NLP. Okay, so now that I've got the import done, I need to create myself a little function called train model. So this is the first thing that we are going to do, is we are going to essentially feed all of those variations of what time is and then train that underlying model. So I need to create myself an NLP manager. So we will just do const manager is equal to new NLP manager. And we are going to pass in languages, and we are going to set that to English. So that's going to be EN. And then I'm going to just set this flag force NER is equal to true, i.e. I want it to do some name entity recognition. Now, of course, if I wanted to support multiple languages, then I could just add in some other language identifiers. You know, it could be Spanish, it could be whatever. But for just now, I am just going to stick to English. So now what I want to do is train the model on different time questions. So we will just add that in. So we'll say manager.add document. And we are going to say it's going to be English. And then I'm going to put in something like, what time is it? And then what I now need to do is I need it to come back with a classification. So in this case, all of these queries need to come back with the same classification. So in this case, I'm going to just set it to time check. And now as it recognizes that. And of course, I can just extend this out with different queries that I want. So we'll put maybe 4 in there. So we'll say, can you tell me the current time? So now that we've got a bunch of variations, we just need to train and save the model. So we'll just do await manager .train. And then once that's done, we will just get it to save the model. And then we'll just return the manager as well, because I think we're going to want that a little bit later. Now that we've got our function for training the model, I need to create a function that's just going to return the time. So now that I've got a function that returns the time, what I want is a function that is actually going to pass the incoming query from the user, i.e. what's the time, tell me the time, whatever, and then going to go infer the model and then get what the classification of the time is. So to do that, I will just create a quick function, which is going to be called getResponse. And I'm going to pass in essentially 2 things. One is going to be my NLP manager, and the other thing I'm going to pass in is the actual query. So to interact with the model, we just need to, we'll get a response back, but we just need to essentially call manager.process and pass in the language that is coming in this case English, and what the query is. So what time is it, tell me the time, etc. And then all we now need to do is just do a check of if response.intent is equal to time.check, which is what we set our classification up here above. Then if that all works, we can return the current time is, and we will put get current time. And of course, if it's not a time check, then we don't know what it is. We can return something like, I have no idea what you're talking about, dude. So finally, all we need to do now is create a main function where we're going to pass in our query and then get the response. So the first thing we will do is train the model. So we'll say const manager equals await train model, which was the name of the function we created earlier. We'll set our user queries. Then we will then just pass that query to our get response function. So await get response, we'll pass in the manager and we'll pass in the user query. And then finally, we will console log out the response. Let's just call our function. And now that we build that, we can just run nlp test by doing run nlp test.ts. And then it's going to train the model with those classifications. And once it's trained, it's going to pass in the query that we just sent, and then we will find out whether it meets the classification or not. So we'll just run that. And you can see the sort of all of these epochs. The epoch 35, that's where it's doing the training. So at this point, after 35 epochs, it's pretty well trained, and then it comes back with the current time is 7:47. And of course, if I change this query, rather than saying what is the time, I say something like, what is your name? Run this, and you can see the bad news with something like nlp.js over something like large language models is large language models are generally quite better, which is why you have these terrible chatbot experiences that I'm sure that everybody has had. So the problem is if I put this through just as it is, what's the time? Can you tell me the current time, etc. The problem is most things are probably going to get classified into that bucket because it's just not that good. But for something like training an agent network, that's going to be fine. Now, to try and make this a little bit better, what I can do is add in more classifications, and therefore it's more likely going to go off to something else. So I am just going to add in a bunch here, which is going to be things like catch you later, bye for now, hey, hi, hello, hi, etc. And now rather than going to time check, they are now going to go to things like greetings, bye, greetings, hello. So it gives you an idea. So if you've ever seen these sort of chat bots that people create, on your website, I'm sure you've seen a ton of them, for things like banks and contact centers, all that sort of thing. This is pretty much the technology that sort of powers most of these things. So now that I've got a couple of other categories, I've got time, I've got bye, I've got hello. What I can now do is change my get response to handle those variations. So now I'm going to add in if the response.intent is greetings hello, it's going to say hey, and then if the intent is greetings.bye, then it's going to say bye, and then of course default it hasn't got a clue what you're talking about. Now if I do a bun run NLP test, you can see it's gonna, all of this sort of epochs 45 that came back and it says the current time is 7:59, which is pretty cool. So if I said something like hi there, and now run this, you're going to see it's going to come back with hey. So from a classification point of view, it's understood the classification and it's came back with hey. Now, if I now change that to something like goodbye and run this, it's going to come back and say, I have no idea what you're talking about, dude. So it hasn't recognized goodbye in this sense. And this is where we sort of run into the sort of the problems with something nlp.js is that you just need to have a lot of variations, etc. It doesn't understand what goodbye is. Now if I change that to something like goodbye, and then we'll just run that again, of course it's going to pick up goodbye because it understands all the variations there. But again, maybe if I just then change this from goodbye to bye and run it again, you see now it's got the bye there. So it's flaky, whereas something like kind of Mistral or a GPT is going to get this pretty good. So that's probably the major difference. Now, what you could do is take something like a Mistral or a GPT and then essentially get it to generate all the various classifiers. That could be a nice little cheat to do this quickly. But for our case, this works pretty well. So we've got the basis of our classifier. Now, it's not perfect. Large language models are going to do a lot better, but in my agent networks, this is going to be pretty good. I just need to keep giving it more examples. The big difference between this and a large language model, though, is it's super fast. It's a lot faster than running something like a Mistral or a GPT. It's going to be a lot cheaper, but then I'm paying a cost, and that cost is it's not going to be as accurate. So depending on how good I get that training data, depends on how good I get that experience. And we've all been there. Anyone that's used one of these chatbots, contact centers and all that use, you will have seen that if they've not got a good list of classifiers, a good list of intents, then you're going to get a bad experience because it's not going to understand what you're doing. So now that we understand how that works, what we need to do is integrate that back into our time server. But actually, we're going to do this in a sort of reusable way. So we're going to create ourselves an exportable package. So if you want to see how to sort of export packages in Bun and then import them in, I'm going to show you how to do that. And then that reusable package we'll be able to use for other bots as we create them. So I'm just going to create a new folder called something like NLP model helper, and I will put fun at the end there. So we'll just see cd into that. We're just going to do a bun init. and that's created. We're going to get rid of the index.ts because we're going to create our own. We'll create a source directory. We'll do bun add node nlp as we did before. We'll open up Visual Studio Code, and what we'll do is we'll create a file called nlp model trainer.ts. Rather than watch me type all of this out, I'm just going to put it in here. It's a reusable package. I'm calling it NLP Model Trainer. You're going to be able to pass in what the file path of your model is, what your training data file is going to be. So essentially what this class is going to do is taking a JSON file, which is a training file with all of those different intents that I showed you. That's going to do the model training, so it will load up that training data. There's private load training data, and again, all you're going to see is it's literally going to just do a read file and do a JSON parse. And then I'm going to have a function here that does, or a method that's going to be called train and save model. So it's literally going to load the training data. It's going to add all the documents from your JSON file. So we saw this already. And then it's then going to train the model, train the model and save the model to your file system. And then we'll just export that out. So that's literally all it's doing. I've shown you all of this before. And then similarly, we're going to need a NLP model loader. So we'll call NLP model loader .ts. And we'll paste all of this in, so which is cool. Again, same sort of thing. Previous class was about training a model. This is about loading an existing model. So you can kind of see from a constructor perspective, I'm going to take the path of the model. We're going to check if it exists, and then we're just going to load or train the model. So you see here that this, it does a quick check to see if it's there. If it doesn't, if the model doesn't exist already, it's just going to essentially use the trainer that we created a second ago and train the model. If that file path does exist, then it's just going to load that model. And then once the model's loaded, you see it's going to load the model. And then essentially all it's going to do is be there and available, return that NLP manager that we used earlier, and then you can use it. So it's a nice little sort of helper utility. Last thing that I need to do is just export all of this. So in my index.ts, I'm just going to import NLP trainer from NLP model trainer. So I'm just going to import from my source directory there. And then I'm going to export NLP model loader and trainer. And then that is going to allow me to export this as a local package. And I'm going to do this as a linkable package. So I'm going to go into my package JSON. I'm going to get rid of this module here for a second. And then I'm just going to put in here exports. And I'm going to set this to a libindex.js. And this is important because what I need to do is do a build of this, and then I need that to go into this lib folder. So I don't want it to access the TS files directly, TypeScript files. I need to compile this down into, or transpile this down into JavaScript files. And therefore, when I'm exporting this out of my NLP model helper, fun package, then what we're going to look at is the compiled version, which is this index.js. And just for fun, I'm just going to put a version in here as well. So we'll just set that to version 0.1. So now that we've done that, we need to build our package because we're going to set that up to link later. So I'm going to do a bun build source index.ts. And we're going to set the target as bun. And I'm going to set the outdoor as lib, as we said there. It's now created that. So if we look here, there's now a lib folder. If I open Visual Studio Code here, in this lib folder is my index.js. So there's the transpiled version of my package. And of course, if I look at that package JSON, that is what I'm exporting, is this index.js, which of course is the transpiled version of my index.tx, which is essentially a load of exports of this and this, which is my loader and my trainer. So I've now got a nice reusable utility. So what I can now do is integrate that into this time service. And there's a few things I am going to need to do. I'm going to need to create myself a data directory, which is going to store my JSON. What we will do is within here, we will create a new file called timequeries.json. Essentially, the format that it's going to take is a JSON file. It needs to be of arrays. And essentially, it is going to be something like query, and then what my query is going to be. So we can say something like, what time is it? And then the intent is going to be time.check. And then I'm just going to create a bunch of these, so we can take this and we can go paste, 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 all right? And if we can come back into NLP test, we can start copying these things across. So we can say, put in, can you tell me what the current time is? We'll put that in here, and then we will just keep doing the same thing across the board. We've got our, our configuration file for our intents. Now what I need to do is create another folder where we are going to store our models, and that will be called models. So now what we're going to do is modify the time server to essentially use the new classifier. So I am going to create a new file called index2.ts. It's just because I don't want to mess up my original index. To just go through this quickly, it's the same time server that we did in the original video. All I'm now doing is I'm importing my NLP model lore from my NLP model helper fun that we just created. We'll do the bun link in a second. And then as you can see here, the model directory is models, which is here. The data directory is there. The training data file is timequeries.json, which we just created. The model name is going to be model NLP. So as soon as we train the model, it's going to save it, and it's going to save it in that models folder. We'll show you how that works there. We've got the get time function, which is essentially going to take the query in from the WebSocket server. It's going to check it, see if it's a time one. If it is, it's going to return the time. Otherwise, if it's a hello, it's going to say hey. If it's a greetings, it's going to say bye. And if it doesn't know, it's going to say I don't know what you're talking about. When we start up the web server, it's going to check to see if there's a retrain argument in there. If there is, it's going to retrain the model regardless of what's in there. We're setting the model path and training data. We're loading the model, so it's using NLP loader that we created. It's going to load or train the model, using that time query JSON there. And then finally, it's just going to come back to bun serve. And then there we go. Welcome to the time server. That's what it's time now. So it's the exact same as we had before. The big difference now, of course, is when we get an incoming message, then you see, so get time comes in there, then it's essentially going to go and look at the get time function that we created here, and then it's going to use the classifier to classify the response. So now that that's all in place, if we save this, I need to come back to my bun model helper, and we just need to type in bun link. And when I type in bun link, that is going to register that package in bun. So we can now use it here. So you can see I can add it to dependencies using NLP model helper fun. So now if I come back into, my application, I can type in bun link NLP model helper fun. I'm just going to hit save. And you see it's installed that package. And now if I come back to VS Code for a second, you're going to see in the package JSON, there's NLP model helper fun with the link. So that is all good. And you'll be able to see it's linked down here. If I look in my Node.js, NLP model helper, link package, very cool. So if I now run index2.ts, you can see it's done the training, and now I'm listening on localhost 3000. If I come back to Postman, I can connect, and you see there, tell me the time. If I hit tell me the time, it comes back with the current time. But if I change it to hello, it is going to say, I have no idea what it's talking about. That's fine. If I say hi, it's going to say hey. There we go. So that's working. If I say bye, and it's going to say, no idea what you're talking about. Let's bring it down to a couple of buys. Still no idea. And then we'll just type buy one more time, and then it's buy. So as you can see, I have now got my model using the classifier. It is not perfect, right? Let's be clear of this. Using nlp.js is a pain. This is why large language models are better. But if I'm wanting to train agent models, I want to train my own large language model, or maybe I want to do a kind of chatbot where I'm doing classification and I don't want to have the cost of using a large language model, which is very slow, I can use nlp.js or another classifier type, or natural language processing library, and it's going to be able to handle those queries. It's not going to be as good as the LLM, but it's certainly going to be faster. And of course, you can always use an LLM like Mistral or GPT to train and get the intents for your classifier as well. Anyway, I thought it'd be fun to kind of show that. The good news is we've moved our time server on. It can now handle different queries. It's not perfect, but it's going to be good enough for training our sort of agent network and our large language model later. So anyway, hopefully you found this video useful. Hopefully you've seen where the flaws of something like a natural language processing like nlp.js is. Hopefully you can see where it's beneficial and where it's good to use, and then hopefully you can see when you would want to use a large language model against something like nlp.js. It is not a perfect thing. LLMs are certainly so much better, hence why they're getting a lot of buzz and traction, but there is some good use cases in there for them. Anyway, I hope this video has been useful, and I will catch you on the next one.